Okay, in this video I'm going to do some basics of how to name carbon chains, how to name alkanes, and so we'll call this Alkane Nomenclature. Okay, you're going to have to know this backwards and forwards because the nice thing about chemistry is that chemists name things in a very regimented, determined way. And so what you learn about alkane nomenclature, you're going to use to name all sorts of different molecules in chemistry, whether it's an alcohol or carboxylic acid or whatever. You're going to have to name the carbon backbone that's the basis of these molecules, and you do it the same way every time. And it's kind of a very scientific way of naming things, but it's consistent and it works, so that if you see a molecule, you'll be able to name it, and if you see a name of a molecule, you'll be able to draw it out. Okay, so let's start. Let's just put a relatively simple carbon chain here. The first thing you always do when trying to name alkanes, or really any molecule, is try to find the longest continuous carbon chain. And so for this, it's easy. We've got 1 carbon, 2 carbon, 3 carbon, 4 carbon. This is a 4 carbon molecule. Each of those are saturated with hydrogen, so it's just an alkane. So what do we name 4 carbon molecules? Well, there's a list in the PowerPoint and in your book. And so a 4 carbon alkane is called a butane. Okay, and this is just butane, pretty simple butane. Okay, now let's make it a little more interesting. Let's add another carbon to this. Okay, now this isn't just butane, right? But we want to find the longest carbon chain. Let's write down what to do. Find and name the longest continuous carbon chain. Okay, so for this molecule we can say, well, what are our choices? 1, 2, 3, or 1, 2, 3, 4. 4 is longer than 3, so we're going to do that. You could also imagine going backwards. 1, 2, 3, 4. 1, 2, 3, 4. So we got some choices of how to name this, but definitely our longest carbon chain is going to be 4, and so this is going to be some sort of butane. So I'm going to write butane, and I'm going to write it on the right side of this because I'm going to have to put some stuff in front of it. So it's often nice when you find the longest carbon chain, at least at the beginning of this, is to sort of just outline it. I have accounted for those 4 carbons that I've outlined in red by naming this thing butane. And so how many carbons do I have left to account for? Well, there's this 1 sticking off here. And so that extra one that's not part of my parent butane chain, is a substituent. And so we need to identify the substituents. And in this case, we have a 1 carbon substituent, and so that is going to be a methyl group. And so we don't just have butane, we have methylbutane. Now, we would probably be nice of us to identify where this methyl group is on the butane. Okay, sometimes it doesn't matter. In this case, it's a little redundant, but what we're going to do is try to number our parent chain, number the carbons in it, and then identify which carbon this methyl group is directly attached to. So really, since we've identified these 4 carbons as butane, we have 2 choices of how to number them. We can do 1, 2, 3, 4, or we could go backwards. 1, 2, 3, 4. Okay, now the way you want to number your parent chain is so that the first substituent, it has the lowest number. So that the first substituent has the lowest number. So in this example, that methyl group could either be on the 2nd carbon or if I numbered it backwards, it could be on the third carbon. 2 is lower than 3, so I'm going to choose to number my butane chain 1, 2, 3, 4, and so I'm going to call this a 2-methyl butane. Okay, there are dashes in between numbers and letters. Make sense? Okay, well, let's do something a little more complicated here. Let's start with a carbon chain like this. Okay, now the first thing to do is determine the longest continuous carbon chain. 1, 2, 3, 4. That looks good, but it doesn't have to be just left or right. Maybe I could make something longer if I took a little sidetrack. 1, 2, 3, 4, 5, 6, 7. 7 is better than 4, so this is probably going to be a heptane molecule. You can't backtrack when you're doing this either. You can't say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you can't backtrack like that. It has to be a continuous carbon chain. So 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. This is going to be a heptane. The hept stands for 7. And I'm going to number it 1, 2, 3, 4, 5, 6, 7, because I would rather this methyl group be in the 3rd position than in the 1, 2, 3, 4, 5th position. So this is a methyl heptane, and it's a 3-methyl heptane. Okay, now let's change this up a bit. Let's let's add some more substituents to this. Okay, again, a heptane is going to be my longest continuous carbon chain. Maybe I'll just write it out to make things simple. But in this situation, I have my parent chain, that's a heptane, and I have 2 substituents off of it. Okay, and let's see, I have some choices here. So I know it's a heptane, right? Now the question is, am I going to keep this numbering the same, or am I going to do the numbering backward? And what are my substituents? Well, I still got my methyl group here. On this carbon, I've got 1, 2 extra carbons, and so that's I've got a methyl up here. I've got an ethyl down there. Okay, which of these gets priority in my name, and how am I going to number this? 1, 2, 3. Do I want the methyl to be in the 3rd position? Or 1, 2, 3. Do I want the ethyl to be in the 3rd position? Well, in terms of substituent priority, we always just do alphabetical. And so E comes before M. The ethyl gets priority over the methyl. And so I'm going to number this guy backwards of what we did before. So that 1, 2, 3, my ethyl gets the 3rd position. 4, 5, 6, 7. And the methyl gets the 5th. Okay, now when I add these substituents to the front of my parent chain, I'm also going to use alphabet as a way of orienting them. So I'm going to have a 3-ethyl and a 5-methyl, and I'm going to put the ethyl first, not because of the 3, but because of its E. So we'll have 3 dash ethyl dash 5 dash methyl heptane. Okay, dashes in between letters and numbers. A 3-ethyl, 5-methyl heptane. Okay, let's do 1 or 2 more examples, and then you can practice. Here's a cyclic alkane. So this is easy. What's the longest continuous carbon chain? Well, I could go on forever, but 1, 2, 3, 4, 5, 6. There are 6 carbons in this, and so this is some sort of hexane. Since it's cyclic, I'm not just going to call it hexane, I'm going to call this thing a cyclohexane. And that's the name of this molecule, cyclohexane. Okay. Now, let's put some substituents on it to make it more interesting. Let's do this and that. Okay. Again, at the beginning, sometimes it's useful to highlight your parent chain so it's easier to count how many carbons are in your substituents. So I identified my substituents as 1, 2, 3, 1, 2, 3. I've got a propyl group and a propyl group. What numbering do I use on a cyclic one? Well, you got a lot of freedom with the cyclic one. Really, you can decide which of these carbons is the first carbon. It doesn't matter, right? It doesn't have to be at the start or the end of the molecule since you're in a circle. And so I can say this is my first carbon or this is my first carbon. Again, we want the first substituent to have the lowest number. Since both of these are equivalent, it doesn't really matter at all. I'm just going to call this the first carbon. Now I have a choice about which is second. Am I going to go 1, 2, 3, 4, 5? Or am I going to go 1, 2, 3, 4, 5? Well, you probably guessed you want the numbers of the substituents to be as low as possible. Definitely I want one of these propyls to be in the 1 position, and it's better to have the second propyl in the 3 position than it is if I had it in the 5 position. So you can think of this as I've got a 1 propyl and a 3 propyl. If both of these substituents are the same, we don't call it a 1 propyl, 3 propyl. We can combine these identical substituents to really call it a 1, 3 di propyl. You can have di or tri or tetra, right, to indicate multiple of the same type of substituents. So this molecule here is a 1, 3 di propyl cyclohexane.